Hello everyone. Today in this video we are going to discuss about the data types set and frozen set. So let's see. So we can initialize a set like this. Within these flower brackets we can give data types like integer, float, complex, or even string. All those we can give. The only condition is that you cannot give uh, mutable data types, means the data types which can be changed in between. Okay, so such kind of data types we can't give in this. So let's see, it's not giving us any error. So let's see the type over here. It's giving us set, and let's try to index it. So it will give us error. This is because in set these will not be having any order, any particular order, so you can't index the elements in the set. That's why it is giving us type error. So let's see the length of this set. So if you see, it is giving us 3 because there are 3 elements. But if you see over here, we are adding multiple elements. So you just guess the size of this set or length of this set. You might think it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you might think the length will be 11, but it's wrong, because in set duplicate elements are not allowed. So those will be automatically removed by the set. So it is 5. If you observe over here, the number of unique elements are 5. That is 1, 2, 3, 4, and 6. Okay. So you can use in operator, and you can check whether some elements are in set or not, like this. So it is true, and similarly this is false because it is not present in this. And you can also use not in, which works in reverse to in. Means if it is not there in the set, then it will give us true. If it is there in the set, then it will give us the false. So as now we have discussed, we can add multiple data types to the set, not only like only integers or only float values. It's not like that. You can mix the data types. So here if we see, we are taking integer, string, float, and then frozen set. Let's execute this. So we are not getting any error. And similarly, there is a method called add. So if you want to add any new item to the set, then you can add like this. So I'm giving some float value 8.78, and after this, if we see the set, it is added. And as I said, there is no ordering in this. It got added over here. Sometimes it can be added over here also. So particularly there will not be any order for this. And similarly, let's try to add a list of 1 to 3. Just think of it, whether it will add or not. Mostly it will not add, because we have already discussed like set only accepts immutable elements, whereas list is a mutable one. That's why it can't add. So let's try to add another set within it. It is also not possible because set is mutable. Okay. And if you want to initialize an empty set, you can use this set function. You can't use direct flower brackets, because direct flower brackets, it will think it as dictionary. So in dictionary also we'll use flower brackets, but the only difference is there you will have key value pairs, but here we'll be having only one thing. Okay, like if you observe over here, we have 1 hello 9.32, like that. But whereas in when it comes to dictionary, we'll be having both key and value pairs with separated with colon. And if you want to check the length of the set, it is 0, because we have just initialized it and it is empty. And we can also there are several functions like is disjoint and is superset, is subset. We'll see all those. So here if you see, set1 dot is disjoint set2, that means that there are no common elements between set1 and set2. So it will tell whether is it true or not. If we see the set1, there are 1, 2, 4, and 6, whereas set2, 1, hello, 9.32, and frozen set. So there is one common element, so it will return as false. Yeah, it is returning as false. And let's print set1 and set2. Yeah, if you observe, there is one common element over here. So let's remove some element. So in set you can remove some element using this remove method. Yeah, now if we observe in this set there is no one now. So let's try to remove something like 2 which is not there in this. Then it will give us key error. Okay. So if we are trying to use remove method, then if you give anything that is not there in the set, then it will give us error. But there is some other function that is discard. If you use that, it will work in the same way as remove, but it will not return us any error if you are giving some non-existing element in the set. It will just return us none. Okay. So if we see like 2 is not there, that's why the set remained the same. And similarly, let's give 8.75. Now if you see 8.75 is not there, so it is removing it from the set 2. So it will not give us any error if some value is missing. Okay. And there is some other function to remove elements, that is pop. So in list or in any tuple or in such cases, there also will be having pop, but it will be removing some last element. Whereas if we see over here, there is no ordering over here. So what it will do, it will randomly remove some element. So let's see, it is removing hello over here. Okay. So if you see in this, there is nothing. So let's again, like from set 3, let's pop. Because set 3 is empty, we just created set 3, that's why it is giving us error. So when there are no elements and you are trying to use pop, then it will give us error. And set 1 is just join set 2. We have already removed the 1, and now set 2 are having these two values, whereas in set 1 we are having 1, 2, 3, I guess. So it should return true. Yeah, it is returning true. Similarly, there is each subset, each superset, such functions are there. So what does each subset mean? Set 1 is like set, these set elements are completely present in set 1, then we can say each subset. So instead of each subset, we can directly use set 1 less than set also. Okay. So this is false. Let's see. Set is this one and set 1 is this one. So in this 1, 2, 3, 4 and 6 are there, whereas in this 1, 2, 3 are there. So actually set is subset of set 1, but we are trying to do it in reverse, that's why it is giving us false. Let's do set is subset of set 1 or not, it will give us true. Okay. Similarly, superset is the reverse one. Set 1 is superset of set, yes, true, and set is superset of set 1, it's false. Okay. And we are initializing set 3, and we can directly use greater than and less than instead of these each superset, each subset functions. So greater than or equal to means either each set 3 should be equal to set, or set 3 should be superset of set. In such cases, it will give us true. Yeah, it's true, because 1, 2, 3 means both are same. Here also we are having 1 to 3 only, and in set also we are having only 1 to 3. That's why it is giving us true. Similarly, this will also give us true, and even this will also give us true. Okay. So like this we can compare the sets. Okay. And there is some other method, that is union, which will add the elements from other set as well. So here we are unioning set with set 1. So this will be our result. And if you observe set 1 and set, these are not getting changed. We are applying it on set, but it is not getting changed. So using these functions, it will not affect the set or set 1. Okay. It will just give us the result of that operation. So you can also write, instead of writing like this, you can also write like this. Even then you will get the same result. Okay. And in union you can pass several values, not only one, like set 1, set 2, set 3, like that. So let's see this. even if this is also giving us the same one. And similarly there is intersection, which will give us common elements between those two. So in set1 common elements are 1 2 3. And also here also we can give multiple elements, and instead of this intersection you can directly use this and between, and you can get the common elements. And similarly there is difference function, and in difference also set1 minus set minus set1, sorry. So it will give us empty because in set we have 1 2 3, and in set1 we have like set1 is basically superset of set, that's why it is giving us empty. And let's do the reverse one. Here we are getting 4 and 6, okay, because a set 1 is having 1 2 3 4 6, whereas set is having 1 2 3, that's why we are getting this 4 6. And instead of this difference method we can directly use set1 minus set minus set1, and similarly set1 minus set. And we can pass multiple elements like this also. What it will do, on set 2, that is this one, it will apply set set 1, set minus set 1, okay. So this is our result, and you can directly give these values over here instead of this dot method, okay, remember that. And there is also symmetric difference. What it will do, it is nothing but A minus B union B minus A. That means the common elements will be removed from them, okay, only which are not common will be present in the result. So in set and set 1, in set we have 1 2 3, and in set 1 we have 1 2 3 4 6. So common elements are 1 2 and 3. So we are removing those common elements and we are keeping only 4 6. And similarly in set, if we are having something like 0 1 2 3, and here 1 2 3 4 6, then we'll have 0 4 6, okay. And let's try to apply it on multiple sets. It will give us error. So symmetric difference will be only accepting one argument. Multiple arguments is not allowed. Whereas in case of difference, intersection and union, even multiple sets will, for multiple sets it will work, or multiple parameters it will work. And similarly there is a function dot clear. I hope you know the output now. It will clear the all elements from the set, so it will be empty set now, yeah, okay. And there is something called as dot copy, and this also I hope you guys know. Then if we add something to set 4, it will not reflect in set 3, whereas if you use direct assignment, it will get reflected in set 3. So if we observe over here, we are copying the elements from set 3 to set 4, and set 3 and set 4 are looking the same. And now we are adding 4 to set 4. Now it is 1 2 3 4, whereas set 3 is 1 2 3 only. But instead of this, if we are directly assigning, it will not be the same. Both set 4 and set 3 will change in that case. And there are different methods, like here if you observe union, intersection, difference, symmetric difference, these are one versions of functions. So in this set will not get affected, it will just give us the result. So if you want the set to get affected, and all we call such operations, we can call it as in place. So if you want this intersection to happen in place, then you can use intersection underscore update, okay. Let's see the update functions. So set 3 dot update set 4, it is similar to union, and we can give multiple elements over here. So what it will do, it will directly update the set 3 over here. So let's see. So now set 3 is getting updated. So if you observe, in set 3 we have 1 2 3, and set 4 we have 1 2 3 4. And now if we print the set 3, it is having union of set 1 and set 2. Whereas previously when we use direct union, if we print like this, it will be 1 2 3 only this result will be 1 2 3 4, okay. And in frozens, like there are many other update functions like intersection underscore update, difference underscore update, and symmetric difference underscore update. The only difference is that here if we see, this set will not get affected, these will just result in this output. But here these will not result as any output, but it will change the set that we are passing. Okay, here set 3 will get changed, whereas here set will not change, but it will result as means it will give us the result. Okay, here set will change, but it will not give us the result. Okay, that's the basic difference between these update functions and the normal functions. And these can't be applied on frozen set because frozen set is basically immutable, and in frozen set we can't use functions like add, remove, clear, pop, discard. Okay, all these functions can't be applied on frozen set as it is immutable. Okay, and apart from these, all the update functions whichever present, like these and also this update, all these also not like we can't use them with frozen set. Okay, I hope you understood the concept. And in frozen sets also we can't add mutable data types like list, set and all those. Okay, so I hope you guys enjoyed the video and understood everything about this set and frozen set, and thank you.